Now you already know the parallelogram law of vector addition, triangle law of vector addition and polygon law. Now let us just make some small tabular column over here. It will help you to do problems faster. Like for example, you have two forces of equal magnitude F each inclined at an angle theta. What's going to be the magnitude of the resultant? I mean two forces of equal magnitude F inclined at an angle theta with each other. Your common sense says because both the forces are of equal magnitude, definitely resultant should make equal angle with both the vectors, so it should pass through center. It should bisect the angle between the two. We know if the two vectors are of different magnitude, then definitely resultant will make smaller angle with the larger vector. For example, this is P and this vector Q. So resultant will make smaller angle with the larger of the two vectors P and Q. Clear? This is the resultant of P and Q, and it definitely makes larger angle with the smaller vector or smaller angle with the larger vector. Clear? Smaller angle with larger vector, larger angle with the smaller vector. Fine. But then when both these vectors are equal, there is no preference and resultant is going to make same angle with both the vectors, and definitely it should be theta by 2 each. Okay? So this angle will be theta by 2, this will be theta by 2 if this whole angle is theta. Now we need magnitude of resultant. Fine. Now let me draw our line perpendicular to the resultant now. So this is 90 degree and this is also 90 degree. We know very well component of any vector A at an angle theta is going to be A cos theta, adjacent component. Fine. And if this angle is going to be theta by 2, this component is going to be A cos theta by 2. Fine. Same thing over here. This angle being theta by 2. This is F. So component of this F along the direction of resultant is going to be F cos theta by 2. Okay. So not only the component of this F but also the component of this F. This is also theta by 2, this angle, and even its component towards the resultant will be F cos theta by 2, F cos theta by 2, F cos theta by 2. So this force and this force together will contribute how much? 2F cos theta by 2 towards resultant. Okay, and in fact this becomes the magnitude of resultant because the other components of the forces, I mean this is F cos theta by 2 and another component will be in this direction which will be F sin theta by 2. Okay, F cos theta by 2, F sin theta by 2. This F sin theta by 2 and F sin theta by 2, that is a component of this force, this F in downward direction. If I call this as downward and this is upward, another component of this force in upward direction, it will be F sin theta by 2. This is F cos theta by 2, this F sin theta by 2, and component of this force in downward direction is also F sin theta by 2. So F cos theta by 2 and F cos theta by 2 will add up to give 2F cos theta by 2, and F sin theta by 2 this component and F sin theta by 2 this component, this are in opposite direction, they cancel out, and that means effectively this is going to be the magnitude of resultant of two forces F and F when they are inclined at an angle theta with each other. Okay. Instead of doing this way, you can as well use parallelogram law of vectors. You would still end up with the same answer. Okay. Let me do it here. According to the parallelogram law of vectors, magnitude of resultant is given by root over p square plus q square plus 2pq cos theta. Fine. Magnitude of resultant where theta is angle between P and Q. Over here we are telling both forces are of equal magnitude, that is F each inclined at an angle theta. So P is F and Q is F. I mean magnitude of P and Q is F over here and angle is theta. So resultant is going to be how much? Substitute the values. So you have this P square becomes F squared plus 2 F into F becomes 2F squared cos theta. Fine. So this becomes F squared plus F squared means 2F squared. Okay, I'm just taking F squared plus 2 F into F squared cos theta plus 2 F squared cos theta. Fine. Now here I can take out 2 F squared common. So 2F squared if I take out common, what is left out? 1 plus cos theta, which I am keeping in the root here, and this is the magnitude of resultant. Okay. And this can be written like this. For 2F square I'll write 2F square as it is. And 1 plus cos theta, you all know we have learned in basic maths, it is 2 cos theta by 2. I mean 2 cos square theta by 2 in fact. Okay? Fine. Now, what we can do here is, this out of this 2 2's here, 2 into 2 means, okay, outside the root I can take it 1, 2. Fine. Similarly, F squared outside the root it becomes f. Then we have this cos square theta by 2, which is cos theta by 2 into cos theta by 2. So 1 cos theta by 2 comes outside the root, and this is nothing but magnitude of resultant. Whether you go by parallelogram law or whether you go by component method, which I followed over here, either way you will get the same thing. Okay, so magnitude of resultant is going to be 2f cos theta by 2. Fine. And what about the magnitude of difference? Okay, I mean when two vectors f and f are at an angle theta, what will be the magnitude of difference? Okay, let me just show you here first how to get the difference. Difference means I'm talking about f minus f. Of course, these two f's are not in the same direction. They are in different direction. They are inclined at an angle theta with each other. Two vectors each of magnitude f inclined at an angle theta with each other. We need the magnitude of difference. You know, difference means the vector which is to be subtracted, we negate it and then add it. Fine? Same laws of addition we use it. So this vector f we negate it, so it becomes minus f, and this minus f we add it to this f. Fine? So when you add this minus f and this f, so you know this is going to be the resultant using parallelogram law. So over here using the formula, what you can do is the magnitude of difference becomes p square plus q square minus 2p cos theta. Okay, let me write d over here, difference. Fine. So here it will be minus. Okay, p and q both are equal to f over here. Okay, so this will be the magnitude of difference, where theta is the angle between p and q only, not between p and minus q. So now everything else is same, but here this becomes 1 minus cos theta. Fine, 2f square you can take common, so you have 1 minus cos theta, and 1 minus cos theta can be written as 2 sin square theta by 2, and not cos, 2 sin square theta by 2. So everything else will be same. The only thing is now the magnitude of difference will be not 2f cos theta by 2, rather it is going to be 2f sin theta by 2. Fine. So this is one way to do it. Other way to do it, component method, as I told you. If this angle is theta by 2, I am bisecting it. Definitely this f's component in this direction will be f cos theta by 2. Fine, f cos theta by 2, and it's this component of this f is also f cos theta by 2. So this will be 2f cos theta by 2. But what about the component of this f in this direction? It will be f sin theta by 2, and component of this f, I mean minus f, numerically f, its component in this direction will be f sin theta by 2. So 2f sin theta by 2 will be this, which is the result, you know, difference, magnitude of difference, 2f sin theta by 2. Or you can straight away go this way. Fine. So if f and f are inclined at angle theta, magnitude of resultant 2f cos theta by 2, magnitude of difference 2f sin theta by 2. The problem here is you will remember the formulae, but there is a possibility of forgetting few things. You know, the possibility is of exchange. That means instead of resultant you might recollect it as difference, or instead of difference you might recollect it as resultant. What I mean is, difference, magnitude of difference is 2f sin theta by 2 when f and f are inclined at angle theta with each other. Okay, and magnitude of resultant is 2f cos theta by 2. So you should not exchange them. I mean, you should not tell that magnitude of resultant is 2f sin theta by 2. There's a possibility of forgetting and remembering the wrong way. So how to eliminate that possibility? Test, simple test, you know very well. When f and f are in the same direction, angle is going to be 0 degree between them, and definitely they add up and resultant should be 2f. Is it clear? And that happens only here. You see, if f and f are at an angle, you know, 0 degree, cos 0 is 1, you know, cos 0 by 2 also cos 0. So this is 1, 2f into 1 will be 2f, and resultant becomes 2f. That happens over here. That doesn't happen over here. You know, sin 0 is 0. So when f and f are at angle 0 degree, definitely result should be 2f, we know, and that happens over here. So this should be the formula for resultant. And you know, when f and f are at 0 degree in the same direction, difference means we negate one vector, negate means you take minus f and then we add up. Definitely they become opposite and they cancel out, and difference has to be 0. When f and f are in the same direction, difference means negate one vector and then add, they cancel out, and difference should be 0, and that what happens over here. Okay, because sin 0 is 0 and this difference becomes 0 when f and f are in the same direction. Fine. Anyway, you need not check both the things. If you just check one, f and f at an angle 0, result should be 2f. That happens over here. So this is the formula for resultant. Definitely the other one will be for the difference when two vectors f and f I mean two vectors of same magnitude f incline at an angle theta with each other. Okay, now let's just fill in this tabular column using either this formulae or the way you wish, doesn't matter. You can also go by component method as I told you, but if you remember this formulae, basically you should not say they are formulae, but the results, if you can remember of this tabular column, maybe they'll help you do the problem faster. If you don't remember also no problem, but if you can remember it, well and good, fine. Now let us see. When f and f are at an angle 0 degree with each other, that's quite simple. Definitely resultant is going to be 2f and difference has to be 0. Okay. Now what about when f and f are at 60 degree with each other? Fine. So what will be the magnitude? So what will be the magnitude of resultant? 2f cos theta by 2, cos 60 by 2. I'm talking about 60 degree between two vectors f and f. Fine. So now this f and f are at 60 degree with each other. Okay. So this resultant I need. Fine. So 2f cos theta by 2 for resultant. Cos 60 by 2 is cos 30. Cos 30 is root 3 by 2. Fine. So this 2 cancels, it becomes f root 3. So I'm writing magnitude of resultant as f root 3. And difference, you can use this formula for difference. 2f sin theta by 2. Sin 60 by 2 is sin 30. Sin 30 is half. So it becomes, magnitude of difference becomes 2f. Sin 30 is half. And that is f. So magnitude of difference will be f when two vectors f and f are at 60 degree with each other. Okay. Resultant's magnitude will be f root 3 and difference magnitude will be f. Okay. And now what about when the angle is 90 degree? That's quite easy for all of you to understand when the angle is 90 degree, because we already know, like when mod a plus b is equal to mod a minus b, the angle between the two vectors is going to be 90 degree. Fine. In fact, let's prove it. Let's square both sides. So this side you will get what? This side you end up getting, if mod a plus b is equal to mod a minus b, what will be the angle between the two vectors? It is going to be 90 degree. Okay, let's check that. Fine. So this side, what you do is you square it. You know, mod a plus b is root a square plus b square plus 2ab cos theta. When you square this, root will vanish and you end up like this: a squared plus b squared plus 2ab cos theta on the right hand side when you are squaring this right hand side. And when you square this one, you end up with a square plus b squared minus 2ab cos theta. Fine. And they are equal over here. So what you do is bring this a square this side. So a square and a square cancel out. A square minus a square, b square minus b square, when it comes this way they cancel out. And this is 2ab cos theta, and the other side you have 2ab cos theta. Some of the students do some indolent things. What they do is 2ab cos theta and 2ab cos theta they cancel out, and they'll show that 1 is equal to minus 1. Hope you're not going to do this here. That's not our job here. Fine. So 2ab cos theta, when you cancel out, you'll end up something like this: 1 equal to minus 1, which is absurd. Okay, at least you know that. So what we will do here is we'll bring that 2ab cos theta this side. Okay. So what you can do is you can cancel, if you wish, you can cancel out 2ab and 2ab without bringing this side as well. So what you will end up is like cos theta is equal to minus cos theta. This is possible only when cos theta is 0. Only plus 0 can be equal to minus 0. Or you bring this cos theta this side, you will end up 2 cos theta equal to 0, or cos theta is 0. That means theta should be 90 degree, because we know cos 90 is 0. Okay. So angle between A and B is theta, which is 90 degree over there, because cos 90 is 0. We are getting cos theta 0 here. Clear? So when mod a plus b go to mod a minus b, then angle between A and B is 90 degree. Fine. This is a very clear cut explanation over here. Let us just see it geometrically. Fine. Let's try to understand this concept geometrically, this part. I'll show you. In fact, as an example, I'll show you. So if this vector A is of magnitude 3 units, suppose, and vector B is of magnitude 4 units, we know very well 3 4 means this has to be 5. Okay, that is resultant, or this is magnitude of A plus B. This is 3, this is 4. Angle between A and B, A, this is B, angle is 90 degree over here. So resultant's magnitude mod A plus B is going to be 5. 3 4 means 5, triplet. Fine. What about A minus B? A A minus B means A plus of minus B. We negate the vector B. Suppose this is B, so this is going to be minus B. Its magnitude will be same 4, but it will be in opposite direction. Now, if I need to add A and minus B, that is going to be A minus B in fact. So this is A, this is minus B. Let me add this to using triangle law, tail head, resultant, head, tail. So this is going to be the magnitude of A minus B or A minus B vector, and its magnitude also is going to be 5. Because we know this is 3, 4, 5, 3, 4, 5. Is it clear? So angle between A and B 90 degree, angle between A and minus B also 90 degree. In fact, mod of A plus B and mod of A minus B is same, means angle between A and B is going to be 90 degree. Okay, this is an example over here. This is the explanation. Fine. So we know this is possible when angle is 90 degree. Fine. We will be using this at plenty of places. So over here we just remember, we know in this particular case the two vectors are of equal magnitude f and they are at 90 degree with respect to each other. So magnitude of resultant will be f root 2, f and f, result will become f root 2. Fine. So result is going to be f root 2, and similarly difference also will be f root 2, because we have just shown if the two vectors are perpendicular to each other, mod of a plus b and mod of a minus b is going to be same. That means magnitude of resultant and magnitude of difference is going to be same. That's why you know very well diagonal of a square, if side of a square is a, then diagonal of a square is a root 2. Same thing over here. Okay, here this is f 90 degrees, so this has to be resultant, which is nothing but diagonal of a square, which is f root 2. So difference also should be f root 2. Clear? Let's proceed further. Now what if the angle between two vectors each of magnitude f is 120 degree? Okay, so you know this is going to be the resultant. These two are at 120 degree with each other. We can now show the resultant will now have the magnitude of f and the difference will have a magnitude of f root 3. Okay, you can use the same formula to show this. Now resultant, you know, f and f are at 120 degree with each other. Resultant magnitude also, if you can see, they are almost all of our same size in fact. Okay, in fact they will be of same size, same magnitude. So f and f 120, result will be f and f 60 degree, result is going to be more than f root 3 in fact. Fine, 60 degree f root 3. Fine. Now you can use this. Fine. So what about the magnitude of resultant? It is 2f cos theta by 2. So cos theta by 2, resultant's magnitude. Theta is 120 degree over here. Fine. So cos 120 by 2 is cos 60. Cos 60 is half. Fine. So cos 60 is half and this becomes f. Fine. So that's what we have written here. And what about the magnitude of difference now? When angle between the two vectors is 120 degree, you know, difference will be f root 3, because now you see difference means any one vector you need to negate. This is f, suppose, let me write in blue, otherwise you might get confused. This is f, and now minus f means suppose this particular f I want to subtract, so I need to negate that. Fine. So this is minus f, and this angle becomes this is 120 means this becomes 60 degree. Fine. So this particular angle will be now 60 degree, and f minus f are at 60 degree. Now you need to add these two, you will definitely get f root 3, because we know very well when f and f are at 60 degree, this is going to be f root 3. Same thing over here. This is f, this angle is 60 degree, so this should be f root 3. But that is nothing but magnitude of difference now, because we are negating one vector. Fine. So difference will be f root 3. You can also use this formula to get that. Okay. What about magnitude for difference? 2f sin theta by 2. What about sin theta by 2? Sin 120 by 2 is sin 60. Sin 60 is root 3 by 2. And this 2 cancels out. You will end up with getting f root 3. Okay. And what about when the angle between the two vectors of equal magnitude is 180 degree? See, f and f are at 180 degree now with respect to each other. They are in opposite direction. Add up, what you get? Obviously 0, because they are in opposite direction. They just cancel out. Add up, you get 0. Fine. So magnitude of resultant will be 0. And what about difference? Difference means, we negate one vector which is subtracting. Suppose I am subtracting this vector. So this vector I need to negate. Okay. So this becomes minus f, this f and this minus f. Now when you add these two, obviously you get 2f. Fine. So in fact what I am trying to tell you is these two vectors f and minus f are, f and f, magnitudes f and f are in opposite direction. Fine. When you add up you know they cancel out and result is 0. Subtracting means one vector we negate. So definitely negate and then add. So definitely f and f in same direction now. At least two vectors each of magnitude f will be in same direction. Then definitely result is going to be 2f, and that is nothing but difference. So we are negating one vector, so you get difference, and that is 2f now. Fine. Even this formula will give you the same thing. Fine. Like over here, you know, when angle is 180 degree, when two vectors of equal magnitude f and f are in opposite direction, angle is 180 degree. So theta is 180, cos 180 by 2 is cos 90, cos 90 is 0, and resultant's magnitude becomes 0. Clear? Similarly, when theta is 180, when two vectors of equal magnitude f and f are at opposite direction, sin 180 by 2 becomes sin 90, sin 90 is 1, so 2f into 1 is 2f, and that's why I have written for 2f. In fact, you can just proceed up and down, like see, over here 0, f, f root 2, f root 3, 2f. Fine? Is it clear? And you need to remember only few things over here. In fact, most of you would easily be able to remember this part and this part, because we know when f and f are in same direction, definitely result is 2f and difference will be 0. That's okay. Now coming to this part, when f and f are in opposite direction, we know when you add up they cancel out. When they are in opposite direction, when you add up, result will be 0, and definitely difference means one vector we negate and that becomes 2f, so that is also clear. And you also know when two vectors of equal magnitude f and f are mutually perpendicular, then this will be f root 2, okay, resultant. And even difference magnitude of difference will also be f root 2, because we know mod of a plus b mod of a minus b means angle between a and b is going to be 90 degree. Fine. So magnitude of resultant or difference is going to be same when angle between a and b is 90 degree. Over here angle is 90 degree, and one more thing is they are of equal magnitude f and f. So diagonal of a square f root 2 like, difference also will have the same magnitude f root 2, so that part also you will remember. The only thing you need to separately remember over here is this part, that is 60 degree part and 120 degree part. Even that it is quite easy for you to remember. In fact, after listening to this video once, you should never forget it, okay, and you should never need this formula in fact to remember these values right from now till at least you face your entrance examination, okay. So maybe couple of years at least you should not forget this. You should not need to use this formula in fact, okay. You don't need to use this formula at least, okay. Let us see how you can remember that. It's so easy, you know. F and F are at 60 degree. Okay. By seeing the figure itself, you know, the resultant's magnitude will be more than F. So, you know, it should be F root 3. Of course, the confusion will be like whether when angle is 60 degree, whether result will be F root 3 or difference will be F root 3. F root 3 you need to remember at least, and one is F root 3, other is F, that you have to remember it, fine. And now because it is longer, it should be F root 3 and not F, okay. So that way you can remember when angle is 60 degree between F and F, result F root 3 and difference F, obviously, fine. And when angle is 120 degree, we know very well, now this is F and F at 120 degree. Now result will be smaller because you can complete the parallelogram over here. Fine. And you will end up getting a smaller value. This is F in fact. Fine. This smaller, it's almost equal to this. So it is F. Fine. So F and F but 120 degree. Result will be F and difference will be F root 3. That way you need to remember. So F and F at 60 degree. Result longer. So F root 3 difference F. F and F at 120 degree. Result is, you know, smaller. In fact it should be F and difference will be F root 3. That way you need to remember, okay.